Hello students, welcome to Monday's math class with Mrs. Berg. Today we are in lesson 16, which is called Common Factors. So for today's lesson, you're going to need your notes and a pencil, and probably a highlighter is always good to have on hand. All right, so let's get started. This week, we're doing the last couple lessons of Unit 7. And then we'll be wrapping up Unit 7. So the first part is something we would have done in class together. It's kind of one of those, what do you notice? What do you wonder? What's alike? What's different? So we'll spend just a couple minutes doing just this activity just to get ourselves warmed up. If you notice, it says that these are all a bunch of figures made of squares. How are the pair of figures alike? How are they different? So I kind of want you to do what I did on my paper. Let's write a section for how they're alike, and then let's write a section for how they are different. Now, it's talking about the pairs of figures, right? So here's a pair, here's another pair, here's a pair, and here's our fourth pair. So we want to look at these and kind of see how are these different, how are these alike? All right, so if I'm kind of looking here, the first thing that I noticed is that I know that like one's lightly colored and one's darker. Had this been a color picture, the lighter color would have been yellow, a bunch of yellow squares, and the darker squares were supposed to be blue. So if you happen to have a yellow and blue, you could certainly do that, or you can just kind of look at mine. So I'll just kind of use this first one just to kind of get you in the hang of things. So when I noticed all these pairs, I noticed that they're different because each of them are a bunch of different shapes. So the one thing I noticed was simply that they had different shapes. There was a difference. Of course, easily, they're different colors. So then I'll put the different colors. One's yellow and one's blue. Okay, yellow, blue, yellow, blue, yellow, blue. I also kind of noticed that sometimes if you notice that the squares are nice and even, there's like no like leftovers hanging around, like these are nice and even, here's an even one, here's an even one. But then sometimes there's like an odd, like extra shape or two kind of hanging around. So maybe I'm just gonna say odd extras. Now for their alike, I could simply say, well, each set has a yellow and a blue. So I could say Y and blue. They each have a group of yellow squares and a group of blue squares. And the one thing that you may have already noticed, that each of these, the yellow, there's 6 of them. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 4, 6. 2, 4, 6. And the blues all have, I think it's 10. 2, 4, 6, 8, 10. 3, 6, 9, 10, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. So we can say there are 6 yellows and 10 blue. Okay, just a little kind of warm up. Now, if you notice, the name of today's lesson was Common Factors. All right, so a quick little review on what is a factors. Factors are two numbers, let's define this please, that when you multiply, so I'll use the X as a multiply symbol, together, they create a number. Okay, examples would be if I had something like the numbers 2 and 3, when you multiply 2 times 3, you get the number 6. 2 and 3 would be factors of 6. You multiply them together, you get a number. Another example might be 2 times 5, and that gives you 10. So 2 and 5 are factors of 10. You should have done this in 5th grade, so it's kind of a review, but we haven't done it all year, so I'm going to kind of show you some different ways to find factors of numbers, and ultimately you're going to pick the way you find is most easiest. So let's go ahead and get into the heart of today's lesson. A lot of these lessons have stories behind them, so they're what we call real world applications. All right, Diego's bake sale. Diego is preparing brownies okay, and cookies for a bake sale. He wants to make equal-sized bags, all right, for selling all of the 48 brownies. So he made 48 brownies and 64 cookies. Organize your answer to each question so it can be followed by others. So here's the main question, and I think we've got a couple of parts of this question that we have to figure out. The first one is asking us, how can Diego package all of the 48 brownies so that each bag has the same number? So right now we're going to focus on just the brownies. So if you're trying to find out how many brownies can go into bags, you're really going to find the factors of 48. So we want to factor the number 48. We want to find all the numbers, and when you multiply them together, they'll get to 48. Now, here's where there's a couple different methods. There's something called the rainbow method. Okay, maybe you learned this last year. Rainbow method. Okay, and this is how it works. You start off with the number 1 on one side, and then down here, we put the number itself, because we know that 1 times 48 is 48. Then we kind of go back and forth, kind of making a rainbow. Okay, so these two would go together. Then we go to the next number 2. Does 2 go into 48? Hopefully you said yes, because it goes into 48 24 times. So here is another set of factors. Okay, then we go 3, and we have to think to ourselves, does 3 go into 48? And it does 16 times. So 3 and 16 are another factor. 4, yes it does. 4 goes into 48 12 times. Those are factors. 5 doesn't go into 48, but 6 does when you multiply 6 times 8. And then 7, no. 8, yes. And then we go back again. 8 and 6, 12 times 4, 16 times 3, 24 times 2, and 48 times 1. So that's why it's called the rainbow method, because we can make like rainbows and then upside down rainbow. That's one method. Another method is simply to do a tree. I'm going to show you this way. So we again have our factor of 48. We make tree branches, kind of like a part of an arrow. And again, we go 1 and 48. Then we go 2 and 24, 3 and 16, 4 and 12, 6 and 8. Now the thing with this is you'd have to remember then that while we started 1, 2, 3, 4, 6, and you kind of have to loop back around, and then we go 8, 12, 16, 24, and 48. So they kind of can go both ways. That's the one thing now that you're in 6th grade that you need to understand. All right? Another way, okay, which is kind of the way you'd want to use for this method, because we have to find all the bags, okay, is to then make ourselves a T-chart. Okay, and here are the bags, and this would be the brownies. Now, if I just told you just factor 48, you guys could use the rainbow method or this kind of like tree method. But because it's asking us that they need to figure out all the different bags they can make and how many brownies, a T-chart works really good for this. All right, and I'll show you why. So if we just had one bag, we could put all 48 brownies into that one bag. That's it, we could stop there. Or if we want to spread our brownies out so that we can give them to more people, we could then say, well, if I have 2 bags, I could put 24 brownies in each bag. Just split this 48 in half. Oh, well, what if someone said, no, we need a lot more than 2 bags? Okay, 3 bags, and I can put 16 brownies in each bag. Nope, need more bags? Fine. 4 bags, and I could put 12 brownies in each bag. Nope, need more bags. Great. I have 6 bags. I can put 8 brownies in each bag. Now, this is where the chart kind of flip-flops. If I have 8 bags, I can put 6 brownies in a bag. If I have 12 bags, I could put 4 brownies in a bag. If I have 16 bags, I could put 3 brownies in a bag. If I have 24 bags, I could put 2 brownies. So maybe I had 24 students this year, and each student would get 2 brownies. Last but not least, if I had 48 bags, I could put one brownie in each bag. Maybe I was trying to feed 48 people. So this, okay, is really the true answer to the question based on us trying to figure out how many bags do we need, how many brownies would go in each bag. If you're feeding a lot of people, well, you want to be down here. If you only have a couple people to feed, well, obviously they're going to get a lot more brownies. So that's kind of the thought process I want you guys to stick in your brains as we go through this lesson. So this answer here, guys, is really, okay, the answer to the top of this question. We just put all the work. So I'm just going to say see previous page. All right, because this also was part of question number 1. All right, let's go down here and look at question number 2 together. How can Diego make all 64 cookies? Okay, so now we're going to focus on the cookies so that each bag has the same number. So we're pretty much doing the exact same thing we did on question 1, but this time we're doing the cookies. So we want to factor out 64 to see, all right, how many bags we can make and how we can split up the cookies. So because I know that we're doing the same thing as question 1, I'm just going to go ahead and start off with my T-chart right from the bat. So again, I've got number of bags, and this time I have cookies. And we're going to factor the number 64 into a T-chart, just like we did with the 48 brownies. So if I have one bag, obviously I can put all 48 cookies into the bag. But if I have 2 bags, I need to split this 64 into 32. 3, unfortunately, doesn't go into 64 evenly, and I can't put like half of a cookie in a bag, so 3 bags are not going to work. But 4 bags will work because I can split 64 up into 16 cookies. Does 8 go into 64? It does 8 times. So if I have 8 bags, I will put 8 cookies in each bag. Now we're just going to kind of flip it around, all right, and go back to our number 16. If I have 16 bags, obviously I already did it up here. Now there's 4 cookies per bag. I have 32 bags. Each bag will get 2 cookies. And if I had 64 bags, there'd only be 1 cookie per bag. Again, this is going to help me decide how many cookies and how many bags I want. All right, and that's all you had to do there. If I asked you to factor the number 64, okay, you can again simply do the kind of like make like a little table, and it would be 1 and 64, 2 and 32, 4 and 16, and 8 and 8. Those would be all the factors of 64, all of these numbers here. You could also do the rainbow method, but most students when they get to 6th grade kind of prefer this method. It's quick, it's easy, it doesn't take up a lot of room. Question 3, now it says, how can Diego package all of the brownies and the cookies? So now it's going to put the 2 together so that each bag has the same combination of items. All right, here. How many bags can he make, and how many of each will be in each bag? Find all the possible solutions. All right, so basically now we're going to combine information from question 1 and question 2 together. So what I'm going to do is make another chart and putting everything in one now. So again, I've got my bags. I've got my brownies. I'll do BR for brownies, and I'll just have C for cookies. So now I'm going to see how these 2 numbers are going to be together. So before I even start putting a bunch of numbers in the chart, I'm going to write down my factors of 48 and 64 one more time. All right. Now I already did this, but I'm just going to kind of put them now in just a one long list. So when I did my 48 on the previous page, I had 1, 2, the number 3, the number 4, the number 8, the number 12, the number 16, the number 24, and the number 48. And if you're confused as to where in the world, Mrs. Berg, did you get that? Well, real quick. Okay. That's just when I did my rainbow. Okay, these are all the factors. All the factors here, 1, 2, 3, 4, 6. 8, 12, 16, 24, and 48. Now I'm just going to pull my 64 from right up here. So I'm just going to go straight down and find my factors. 1, 2, 4, 8, 16, 32, and 64. Okay, so I just pulled them straight from the charts we made. You could also go over here and pull them from the trees that you made. Okay, whatever place you want to pull them. So now I'm going to look at these and I'm going to see, where do I have similar numbers? Okay, like where do I have similar numbers? All right, well obviously I see that they both have a 1 in common. They both have a 2 in common. All right, this one has a 3, but 64 does not. But they both have 4s in common. I see the number 8 in common. Now 48 has a 12, but 64 doesn't have a 12, so I can't use 12. But I can use 16, and then these last ones not in common. So all I care about right now are the common factors, the factors that 48 and 64 share. These are the ones I'm going to plug into my chart, all right? So according to one bag, okay, if I have one bag, okay, I can put in 48 brownies and one bag is 64 cookies, all right? Because again, my 1 and 64 went together and my 1 and 48 went together. They also share, okay, a common factor of 2. So if I have 2 bags, okay, when I did 2 bags, I could put in 24 brownies, and when I did 2 bags, I could put in 32 cookies. They didn't share a 3, but they shared a 4. Okay? So if I have 4 bags, I knew that I could put in 12 cookies. 12 brownies. And over here, when I shared a 4, I could also put in 4, and I could have, did I do that right? 16 cookies. Yeah, 4 and 16. There you go. They shared an 8. Okay. When I had 8 bags of brownies, I could put in 6 cookies, because 8 times 6 is 48. And when I had 8 bags of cookies, I could put in 8 cookies, because 8 and 8 is 64. And lastly, it looks like the last common factor is a factor of 16. When we had 16 bags of brownies, okay, I could put in 3, because 3 times 16 is 48. And I could have 4 here. So hopefully you kind of understood how I did that. So obviously, based on how many bags you want to make, this would tell you how many brownies and how many cookies would go in each bag. If you just gave one huge bag, well, all of your brownies and all of your cookies would go in there. 2 bags, 4 bags, 8 bags, and 16 bags. Okay, so that's kind of what we're doing with these type of problems today. All right, let's see what it's asking us for number 4. I think it's the last question for this. What is the largest number of combination bags that Diego can make with no leftovers? All right, explain to your partner how you know that this is the largest possible number of bags. Well, if we look at the chart we just made, what was the largest number of bags we were able to put together? And that was 16 bags, which then each bag would have 3 brownies and 4 cookies. So that's kind of the answer. Well, that is the answer. So let's write that down together. The largest number of bags would be 16 bags. And that, therefore, in each bag, we put in 3 brownies and 4 cookies. It's making me hungry doing this math with you guys today. All right, good job. So that's how you would take a real problem and kind of solve it. Let's move on to 16.3, greatest common factor. Okay, so this should kind of be a review for you. Now that we know how to find all the common factors of a number or numbers, now we're going to be focusing on, well, what's the greatest common factor? Okay, the greatest number that those numbers would share. So let's look at this first problem. It says the greatest common factor of 30 and 18 is 6. So they already found it for us. 2 numbers, 30 and 18, and they're telling us the greatest number is 6. What do you think the term greatest common factor means? Well, let's define it. this would be the largest common factor two numbers share. That's how we would define greatest common factor. And again, quick little review in case we forgot how to do this. Okay, if you have 30 and you have 18, all right, and you were asked to find the greatest common factor, if I told you to make a rainbow list, okay, you could do, well, 1 and 30. Then you go to the next number, 2. Does 2 go into 30? It does, 15 times. Does 3 go into 30? Yes, it does, 10 times. Does 4 go into 30? 4 does not go into 30, but 5 goes into 30. How many times? 6. And then now you're back at 6, goes into 30 5 times, 10 goes into 30 3 times, 15 goes into 30 2 times, and 30 goes into 30 1 time. Let's do the same thing for 18. Let's make a rainbow list. 1 and 18, 2 and 9, 3 and 6, 4 doesn't, 5 doesn't, now we're back to 6 and 3, 9 and 2, 18 and 1. So there's your list of factors for 30. Here's your list of factors for 18. What's the greatest common factor? Well, they share 1s, they share 2s, they share 3s, they don't share 5s, they share 6s, they don't share. So here's how they got their answer of 6. Is a quick little review. That's one of the quickest methods to solving common factors and greatest common factors. Number 2 says find all the factors of 21 and 6 and then identify the greatest common factor, which again is often just abbreviated the GCF. So 2 ways to do it. You could make your little factor trees. We'll do those first. So 21, it's 1 and 21. 2 doesn't go into 21, but 3 does 7 times. 4 doesn't, 5 doesn't, 6 doesn't, 7 doesn't. Then we're back with 7 and 3, 21 and 1. 6 is an easy number. We have 1 and 6, and we have simply 2 times 3, and then 3 times 2, and then 2 times 6 times 1. Or again, just to show you some alternative choices, we could make the rainbow list of 1 and 21, and 3 and 7, and for 6 it would be 1 and 6, and 2 and 3. Okay, so either method, making a tree, making a rainbow list works. Now let's find the greatest common factor. Yes, they share 1s, they don't share 2s. Yes, they share 3s, they don't share anything else. So the greatest common factor in this problem is 3. Number 3, find all factors of 28 and 12. Then identify the greatest common factor of 28 and 12. Okay, so again, pick your method. You could do the trees, you could do the list. I'll do both so that you can see, because I don't know what you're going to pick. So here are the trees. We have 1 and 28. We have 2 and 14. And we have 4 and 7. And then again, 7 and 4, 14 and 2, 28 and 1. 12, we have 1 and 12, 2 and 6, 3 and 4, and that's it. If you want to make the lists, 28 and 12, we have 1, 2, 4, 7, 14, and 28. 12, we have 1, 2, 3, 4, and 12. And I just literally just copied them right from these trees. Looking for greatest common factors, I see 1s, I see 2s, I see 4s, nothing else. So the greatest is 4. Right? That's just solving straight greatest common factors and factoring. Our last problem, I believe, is number 4. Let's see what's going on with number 4. Okay, it's probably another real world problem. A rectangular bulletin board is 12 inches tall and 27 inches wide. Elena plans to cover it with squares of colored paper that are the same size. All right, the paper square come in different sizes. All of them have whole number inches. So she wants to find how big does her square, what is going to be the length and the width of a square so that she can fill up this bulletin board. So what we're really wanting to find out is what is the greatest common factor of 12 and 27. This is what we have to figure out. We can figure out the greatest common factor. We know how big to make our little squares. So, again, if some students like to draw a picture, all right, so if you wanted to draw just a little visual, this is the bulletin board. Think of it like maybe the bulletin board that's outside our classroom. And it is 12 inches high, and it's 25 in its length. And she wants to fill this up with a whole bunch, right, of little squares, okay? I'm just kind of free drawing this. And she wants each square to try and be the same length. Let's see if that's even possible. So the first thing let's do is find the greatest common factor of 12 and 27. So again, we have 12 and we have 27. Let's make a rainbow list. 1 and 12, 2 and 6, 3 and 4. Okay, that's it for 12. Let's look at 27. There's not that many. Okay, there's 1 and 27, and there's 3 and 9, and that's it. So, greatest common factor, they share 1s, they share 3s, and nothing else, so 3 is the greatest common factor. Okay, that means her square, let's first write greatest common factor is 3. That means her square is going to be a 3 by 3 because it's a square. So she's going to have to cut up all of those inside. How is the solution to the problem related to the greatest common factor? Well, basically, if she had these little pieces, okay, so each one of these would be a 3 by 3, all right? We'll say that each square is a 3 by 3 square. Right? That part we can figure out because that's the greatest common factor. So if I have this is 3 by 3 by 3 by 3, and I need to know how many could I fit across. Okay, well, how many times does 3 go into 27? Hopefully you said 9, so I could fit 9 squares across. And then if I had to put 3 by 3s down here, how many times does 3 go into 12? 4, so 4 squares height. Right, so this is my bulletin board. I'd have a 9 by 3, and I could fit the squares in there, all right? And how many total squares? We'd simply take 9 times 4, 36. So I would need to cut 36 3 by 3 squares to fill up my bulletin board. So I already did this part, I just guessed it correctly, but I need 1, 2, 3, 4, 5. I need 4 more to make 9, so maybe I'll divide that there, divide that there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I need one more. 9. So there's how my bulletin board would look. So that's how you could actually use this greatest common factor in the classroom. All right. We kind of already defined common factor and greatest common factor during the lesson. So at this time, guys, it is time for you to work on your practice problems. Okay, again, we're doing lesson 16. You have one Khan Academy in addition to the practice problems. All right. So I want you to pause this video. I have scanned the practice problems into the Google Classroom assignment. I want you to work on them and see if you can figure them out. There's really only 3 problems from today's lesson, and then the rest are review problems, okay? And I've given you lots of notes and little hints on here to help you out. I really want you to try the practice problems by yourself first, and then go back and check them against the video. All right, so we'll see you in a bit. Good luck. Welcome back to It's Time to Check Our Homework and see how you guys did with your practice problem. So let's get right to that. All right, the first problem. was very similar to our brownies and cookies problem we did together in the lesson today. This time a teacher is making gift bags, and she's going to put pencils and stickers inside their gift bags. She's got 24 pencils and 36 stickers. Each bag has to have the same number of each item with no items left over. Okay, so we want to try and see if can we even get the fact that we can't have, like, one bag can't have 5 pencils, another bag have 4. So we've got to find the greatest common factor, guys, of 24 and 36. All right, so the first thing that I really would want you to do is find, okay, all the factors of 24 and find all the factors of 36. So I'm going to do the little tree method here, all right, to get us started. So for 24, I have 1 in 24, I have 2 in 12, and then 3 times 8 is 24, and 4 times 6 is 24. Okay, and remember, these then can go, we can kind of cycle around and go 6 and 4, 8 and 3, 12 and 2, 24 and 1. For 36, I've got 1 in 36, I have 2 in 18, I have 3 in 12, 4 times 9, and then 6 times 6. And then again, we'll cycle around back again. So these are all my factors of 24 and my factors of 36. So let's see where we can kind of share some information. So if I have one bag, okay, I'm going to look at my factor of 1 here. I can put in all 24 pencils and all 36 stickers. But that's ridiculous because there's no way a teacher's going to give everything just to one student. But that's all right. What if the teacher divides into 2 bags? Okay, well, I just look at my chart here. If I had my pencils, there'd be 12 pencils. And for the stickers, there would be 18 stickers. See, this is why I like you to do this first. And it's real easy to fill in a table. What if I want to divide my pencils and stickers up into 3 bags? Okay, well, if it's the pencils, I can put 8 pencils in 3 bags. And if it's stickers, I can fit 12. 4 bags, okay, over here, I can put in 6 pencils and 9 stickers. If I have 6 bags, okay, I'm over here, 6 bags, I could put in 4 pencils and 6 stickers. If I have 12 bags, 12 here, I can put in just 2 pencils and I can put in 3 stickers. Now, if you notice, this is where I kind of have to stop because there aren't any other common factors between pencils and stickers. They both shared a 1, they both shared a 2, they both shared a 3, and a 4, and a 6, and a 12. But that's all that I have to stop there. So basically, if I wanted to have every bag have the same amount, I only have enough to make 12 bags, and each bag would get 2 pencils and 3 stickers. So if I've got more than 12 students in my class, I'm gonna definitely have to go out and buy more pencils and more stickers because I don't even have enough to do more than 12 where it would be even for all the bags. And that's the solution for number 1. Number 2, it's simply you listing the factors of 42. All right, so this is just listing the factors. I suggested for this, just make a rainbow method, make it easy. So you have 1 in 42, and then 2 can go into 42 21 times. 3 can go into 42 14 times. 4 cannot go into 42. Neither can 5, but 6 can, because 6 times 7 is 42. And I'm back at 7 times 6. Then I got to jump all the way up to 14 and 3, 21 and 2, 42 and 1. Again, this is kind of the rainbow methods because, remember, they can kind of go back and forth between each other, either left to right or right to left. Then it says, what is the greatest common factor of 42 and 15? Well, I already have my factors for 42, but let's make my factors for 15. So I'm just going to come right over here and make a quick little, since 15 is a small little number, maybe this time around I'll just do a tree. It's 1 in 15. 2 can't go into 15, but 3 can go into 15 5 times, and that's it. So just those 4 factors, all right? So let's put or you can do the factor list of 1 and 15, 3 and 5. All right, so now let's compare these two together. They share a 1, they share a 3, but those are the only numbers they share. So between 1 and 3, the greatest number they share is 3. So greatest common factor of 3. For 50, okay, let's quickly make a list. 1 and 50, 2 and 25, and then all that's left is 5 and 10. Yeah, that's it for 50, guys. So now we want to compare 42 and 50. So they share a 1, they share a 2, and I don't think they share anything else. Nope. So the greatest common factor is just the little number of 2. Hope you guys are doing well so far. Number 3, a school chorus has 96 graders and 75 7th graders. The music director wants to make groups of performers with the same combination of 7th and 6th grade students. She wants to form as many groups as possible. All right, so we basically have to kind of do where we find the common factors of 90 and 75, and then find out what the greatest common factor would be. That's going to tell us how many total groups can we have. So first let's find, and we're going to do the tree method, all the factors of 90 and all the factors of 75. So hopefully you did 1 and 90, 2 and 45, 3 times 30, 5 times 18, and 6 times 15. Okay, those are all the common factors. And again, we can kind of go back and forth between the two, 15 and 6, 18 and 5, 30 and 3. 75, we have 1 and 75. We have 3 times 25. And we have 5 times 15. So not as many factors in 75, but again, then we can also go 15 and 5, 25 and 3, and 75 and 1. So we have to find which factors do they have in common. Well, they both have 1s, they both have 3s, they both have 5s, and they both have 15. So are the ones that we circle, the ones that they share, what is the highest? Hopefully you recognize 15. Okay, so the greatest common factor is 15. All right, that means the maximum number of groups the choir can have, she has to divide, it's going to be 15 groups. All right, how many 6th graders will be in each group? How many 7th graders? Well, let's go back to our chart. Let's look at the 6th graders. When we had 15 is a factor, okay, the other factor was 6. So therefore, we can have 6 6th graders in a group. And if we come back and look at our 7th graders, again, find the greatest common factor of 15. 5 students, so 5 7th graders. So you could put 6 6th graders and 5 7th graders in each group and have 15 groups and be nice and even with no students left out. All right, number 4. This was kind of, you guys had a problem with this on a recent check-in. Here are some bank transactions for the bank account. Which ones are positive, which ones are negative. I did Monday for you as an example so you could see what type of answer I'm looking for. If you deposit a paycheck, that's a positive plus 650, positive number. Tuesday, you took out $40. Okay, so that's going to be a negative $40. Therefore, it's negative. Wednesday, you got a $20 credit because you returned some merchandise. So that's a plus, positive $20. That's a positive number. Thursday, 125 deduction for cell phone charges. So negative 125, negative. Friday, $45 check written to pay for a book order. So you're paying something. So that would be a negative $45. Negative. $80 withdrawal. Okay, so notice some of these key words here. That would be, again, a negative 80. $10, you got a cash back reward that was deposited. So put back into your account. That would be plus 10, positive. Oops, kind of cut you off there. Sorry about that. Number 5, answer the questions. I gave you a hint. This is using the keep, change, flip because we're dividing fractions. So for this first one, you keep the first fraction. Your division changes to multiplication. You flip the second. Okay, can't do any reducing, so it's simply 8/7. B, keep the first fraction, 12/5. Change the sign, flip the second. Here, you could cross out your 5s, and you're left with 12/6, which reduces down to 2. 12 divided by 6 is 2. C, keep the 1/10, change it to multiplication. Now, this is a whole number, so normally that would just be over 1, so I'm going to flip it, so now it's 1/10. 1/10 times 2/10. 1/10 times 1/10 is 1/100, because 10 times 10 is 100. D, keep the first fraction, change the sign, flip the next fraction. So 10/9 flips to 9/10. 9 times 9 is 81. 10 times 10 is 100. There you go. Quick and simple. Last but not least, an elephant can travel at a constant speed of 25 miles per hour. That's the elephant. A giraffe can travel at a constant speed of 16 miles per half hour. Hint, convert the giraffe to miles per hour first, then compare their miles per hour. It's asking you which animal can run faster. Well, the elephant, we already know, is at 25 miles per hour. So the elephant is at 25 miles per hour. The giraffe can travel 16.5 an hour. So if we want to figure out how far the giraffe can travel in an hour, we'd have to go 16 times 2, which is 32 miles per hour. Now that they're both in miles per hour, we can compare, and who runs faster? Obviously the giraffe, because he can go 32. B says, how far can each animal run in 3 hours? Well, all we have to do now is multiply these miles per hour times 3. So the elephant is at 75 miles. In 3 hours it can travel. And the giraffe is at 96 miles. Oops. And there you go, guys. There are the answers. I hope you guys did fantastic. I want to remind you to do your Khan Academies. All right? You didn't do so well last week. I only had a handful, and I'm talking a very small handful of students that did not do their Khan Academy, that did their Khan Academies last week. So the rest of you need to step up your game and get your Khans done. Okay, there will be a check-in sometime this week, and Friday we're going to be taking our unit test on Unit 7. So good luck. Email me with questions. Bye.